Have you ever stopped to think about how efficiently the electricity in your home is actually being used? There's a term for that. It's called power factor, and today we're going to make it super simple, using an analogy you will absolutely never forget. All right, let's get into it.
Yeah, I know. It sounds a little out there. What on earth can a glass of beer teach us about something as complex as the electrical grid? Well, you'd be surprised. Turns out it's pretty much everything you need to know to make this whole concept just click.
So let's go ahead and pour ourselves a metaphorical pint of power and see exactly how this whole thing works. Okay, so picture this, you've just ordered a nice cold beer. When it arrives, you've really got three things going on. You've got the beer itself, the liquid gold, the part you actually paid for and wanted to drink. Then you've got that layer of foam sitting on top. It takes up space, sure, but you can't really drink it. And finally, you've got the whole glass, which is holding both the beer and the foam. So just remember that, the useful part, the not so useful part, and the total package.
All right, now for the fun part. Let's see how this super simple analogy lines up perfectly with the actual technical terms. We're going to translate our beer model into the real world of electrical engineering, and I promise it's way easier than it sounds.
First up, we have what's called real power. This is the good stuff. It's the power that's actually doing useful work. Making your blender spin, lighting up a room, running a giant industrial motor. In our analogy, this is, you guessed it, the beer. It's the valuable part, the stuff that truly gets the job done.
Next, there's reactive power. Now this one's a little bit weird. It doesn't actually do any physical work you can see, but it's totally necessary to create magnetic fields in things like motors and transformers. Without it, they just wouldn't run. So it's essential, but it's not productive. This is the foam on your beer. It has to be there, it takes up space, but it's not quenching your thirst.
And that brings us to our third term, apparent power. Just like the name implies, this is the total power that appears to be used. It's the combination of the useful real power, the beer, and that necessary but unproductive reactive power, the foam. So this is the entire glass, the whole shebang. It's everything the power company has to generate and send your way.
And this quote just ties it all together beautifully. Think about it. A good power factor just means you've got a glass with a lot less foam. You get way more actual beer, or useful power, for the total volume the glass can hold. So the goal is obvious, right? Maximize the beer and minimize that foam.
So what's the big deal? Why should we care if there's a little foam in our electrical system? Well, it turns out that foam, that reactive power, has some very real and very expensive consequences. Let's break down why this actually matters so much. Let me throw a number at you, 0.70. This is an example of a pretty poor power factor. The best way to think about it is like an efficiency score. A perfect score is a 1.0, so 0.70 is kind of like getting a C on a test. It means only 70% of the total power being delivered to you is doing any real work. And that other 30%? Yep, that's all foam.
You see, a poor power factor isn't just one isolated problem. It creates this nasty ripple effect. Because so much of the power being supplied is basically foam, the whole system has to draw a much higher electrical current just to get the same amount of useful work done. That means you need bigger, beefier, more expensive equipment to handle it all. And all that extra current running through the wires, it just generates waste heat, which is literally lost energy. And the end result of all that inefficiency? You guessed it, higher costs for everybody.
Let's dig into the real price of having too much foam. First, that higher current I mentioned means you need bigger cables, bigger transformers, bigger everything, and that stuff is not cheap. Second, more current means more energy is lost as heat. It's a law of physics, sometimes called I²R losses, and it's just pure waste. And finally, you better believe the utility companies are watching. They can see this inefficiency, and they'll often slap penalties on the bills of customers with a low power factor because, well, it costs them more to deliver all that extra foam.
Okay, so after all of that, what's the one thing you really need to remember? Let's boil it all down to the ultimate takeaway.
This chart says it all. On the left, you've got a good power factor. Your system is super efficient. Look at that, it's almost all beer. You're getting exactly what you're paying for. But on the right, with a poor power factor, a massive chunk of the energy being delivered is just foam. The power grid has to supply that whole amount, but a huge piece of it is just wasted in the process.
So if you only walk away with one single idea, make it this one. A high power factor, a number that's really close to 1, is always the goal. It's a direct measurement of how efficiently you are using the electricity that's supplied to you.
Less foam, more beer. It's really that simple.
And that kind of leaves us with a bigger question to chew on, doesn't it? We've just seen how our electrical grid has its own kind of foam, a hidden inefficiency that we all end up paying for. And it really makes you wonder, what other parts of our daily lives have their own version of foam? What other hidden waste are we all paying for without even realizing it?